Assalamualaikum warahmatullahi wabarakatuh. Nice to meet you again. Now I'm going to talk about the applications of optimization with more than one variable case. There are two examples that I will cover. Both are economics case. First is the case of multi-product firm, and second is the price discrimination case. Well, don't worry about the economics content. As long as the information is clear, economics students or not should be able to solve the optimization problem. Okay, let's try the first case about a multi-product firm. As it is named, multi-product firm is a firm that produces more than one product to sell. So just like in all optimization process, we need to clarify things before finding and identifying the relative extremums. What do you think will be the common objective of a firm in producing and selling its products? Yes, most common objective is to maximize profit. Knowing this as the objective, so the objective function must be the profit function. Then what the firm can do to maximize its profit? Well, in multi-product firm case, the firm can change number of its output. It can also actually change its number of input, the price level of its products, and other factors. All can become choice variables or things the firm can directly change to maximize its profit. For simplicity, however, let's assume that the firm can only change its products, while the other factors are just given. But since it is a multi-product firm, then the choice variable is not only quantity of a single output, but of more than one output. Having identified this, optimization will be again about satisfying the first and the second order condition. Now let's take a look at the example. We have the following revenue and cost functions. Outputs are variable while prices P10 and P20 are given, thus constants. The objective functions become like this. It's a two-variable case of optimization since our objective P has two choice variables, namely Q1 and Q2. The first order condition requires us to equalize all the first partial derivatives of the objective functions to 0. We partially differentiate P, the objective variable, with respect to Q1 and Q2, the choice variables. Using simple substitution or elimination, we obtain the reduced form of both Q1 and Q2. If, for example, output price levels are 30 and 45 respectively, then we can get number of output 1 and 2 the firm needs to produce here, 5 and 10. How about the second order condition? Well, we just need to find the Hessian determinant and its successive principal minors. With two choice variables, Hessian determinant is this. It is obtained from the following. These are the first partial derivatives calculated previously. From each partial derivative, we get two second partial derivatives that fill the Hessian elements. We now can easily identify the principal minors. H1 is minus 4 and H2 or Hessian determinant is 15. Negative, positive indicates D2P or the second differential of profit. The objective function is negative. It implies that the output level we obtained earlier will maximize the firm's profit. Now let's turn our attention to the second case about price discrimination. In this case, firm only have one type of product, but it charges different group of customers different price. What's the objective? The same, to maximize profit. Thus, profit function is the objective function. The problem, just like before, then is to identify the function. Charging price differently and also setting numbers of output of a single product differently to influence price level means several things. Firm's source of revenue will come from the different group of customers. If there are n group of customers, then there will be n sources of revenue. But since the product is just one, the output differs in terms of quantity only. So we may still have Q1, Q2, and Q3 like in multi-product case, but they are just different quantity of the same output sold to different group of customers. The cost of production, as a consequence, is a function of just Q, or the summation of Q1, Q2, and Q3. Price is a function of quantity of output produced by the firm as expressed here. And with all the situation, then firm's profit can be expressed like this and this. And as we can observe, it is affected directly by number of output produced and sold to different group of customers. So Q1, Q2 up until Qn are the choice variables. So here are what we basically do in optimization process. To make it clearer, let's see the example here. We have the following inverse demand function from different group of customers, price as a function of output. Accordingly, we can get this revenue function. If the cost function is given by this equation, then profit is the summation of the three revenues minus the cost, or this. Given this profit function, the first order necessary conditions requires us to equalize all the partial derivatives of the objective function with respect to each of its choice variables like this. The equations here are easy. We can get all the critical values immediately. Knowing all the quantities, getting us the price level charged to different group of customers. At the end, we can find the expected firm's maximum profit. How about the second order condition? Again, find the Hessian determinant obtained from differentiating the first partial derivative with respect to each choice variable. And here are the second partial derivatives of the objective function. H1, H2, and H3 are negative, positive, and negative, satisfying the requirement for a negative second differential. Thus, convincing us that the resulting profit is a maximum profit. Okay, that's all about optimization with more than one variable case that I can explain at the moment. Hopefully now you can understand and implement the concept in any other application and context. Thank you very much for the attention. See you again in different video and different topic of basic math for economics and business. Assalamualaikum warahmatullahi wabarakatuh.